Hello, everyone. Good afternoon or good morning for wherever you're joining from. Thank you, everyone, so much for joining today. My name is Hannah Dudney, and I'm a research associate with the Engineering Health team here at Kite Research Institute. And I'll get started with some housekeeping items before I pass it off to Talak for our project updates. Some of you may have noticed when you joined and entered the meeting room, your name was changed to a different name, which happens to be my name. Feel free to change your name. We made a slight mishap on our meeting link. If you'd like to change your name, if you go to your face on the screen and put your mouse there, there'll be 3 dots where you can select those and go to rename yourself. First, I'll note that we have American Sign Language interpretation available. And please use the globe icon located at the bottom of the toolbar to turn that on. It will appear as a pop-up as well. There are also Zoom captions available by clicking the Show Captions icon. And next, I'll move on to our land acknowledgement before we begin. Our organization, the University Health Network, operates on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. We also acknowledge that Toronto was covered by Treaty 13 with the Mississaugas of the Credit. Before we begin, just a few more things to note. This meeting will be recorded. However, only the presentation portion will be available on our YouTube page and shared publicly. Our channel is called Engineering Health Research on YouTube. The recording of the Q&A and discussion will not be shared publicly. Please feel free to turn your camera on or off as per your comfort level. We, of course, encourage you to share your thoughts and perspectives with us today on our project. After our short presentation, you're welcome to put your questions in the chat, and we're also leaving plenty of time at the end for questions and discussion. Thank you so much, everyone. I'm going to pass things off to Talak, who will share an overview of our project and updates.
Thank you so much, Hannah. Thanks for everyone for joining today. Yeah, this meeting is really to give a quick update on where our project's been going. We've tried to leave lots of time for you to give feedback and have a discussion near the end, as Hannah said. So I'll get right to it so we have lots of time for that. So I think everyone in the room, everyone that's joining us today is well aware of the problem. We know that wheelchairs get damaged quite a bit during air travel, and we're trying to figure out how to prevent that from happening. The specific objectives of our project are to identify all of the potential causes of this type of damage to wheelchairs and to create a set of recommendations to reduce the risk of this damage. This project is funded by Accessibility Standards Canada. We started in June of 2024, and it's a little bit of an under 4-year project. It'll end in March 2028. So the specific goal that we're going for here is to create recommendations for safely securing, loading, and unloading mobility devices during air travel. And there's 5 approaches, I guess, that we're going to undertake to develop those recommendations, and I'll give you an update on how we're doing on each of those. We'll start with an environmental scan. We felt it was very important to review the work that other people have done in this space, and there have been many. There's many guidelines, standards, and researchers that have put out guidelines and have studied this problem that we've uncovered and we've incorporated. We've tried to learn as much as we can from all of these guidelines to point us in the right direction for what we need to do to build on what other people have done before. We've also identified some some other activities like conferences or expos, like the Aircraft Interiors Expo, where there are people developing solutions for some of the problems that we're going to talk about today. And so this is just a sampling of what we've come across in our environmental scan, but we have spent quite a bit of time trying to uncover what's been done before so that we can build on it. We've also looked at the scientific literature, the academic literature, I should say, in a rapid review. We started with about 600 papers that we found with some keywords and narrowed it down to about 57, many of which have focused on dealing with device damage during air travel. I'll just highlight, so from that environmental scan, there were some key takeaway messages that sort of set the stage for what we're going to try to do. And I'll just go through the list of those and build on them as I talk about some of our other activities. One of the key things that other people have noted is that there's something to do with narrow body aircraft versus wide body aircraft when we're talking about risk of damage. Narrow body aircraft have smaller cargo doors. It can be more difficult to get wheelchairs and other mobility devices into those spaces compared to a wide body aircraft, which normally you would put wheelchairs, normally they would go into a container like the one you see on the top left, or on the left, sorry, on the right side of the screen, you can see a container and a wheelchair strapped into a container. That whole container going into the wide body aircraft means that the wheelchair will tend to be more protected compared to a narrow body aircraft, the picture that you see on the left, what's also called bulk loading. A bulk loading space where there's kind of an open cavernous area where baggage and wheelchairs get stored. Sometimes there can be netting that separates certain parts of the sections of this bulk loaded space, but there seems to be more chances of damage during bulk loading. Part of the challenge, as I mentioned, is the door to the cargo space tends to be smaller on these narrow body, narrower, smaller aircraft. And depending on the design, they can be very challenging to get wheelchairs in and out of properly. One of the things people specifically do with narrow body aircraft, we know that there's some there's some confusion or there's inconsistency, I'll say, about whether or not mobility devices can be laid on their side or tipped to get them to fit through these smaller doors. For example, the International Air Transportation Association's guidance highlights that tipping should be avoided. But in some of our discussions with different airlines interpret this differently. Some say that you shouldn't, that they will never turn a wheelchair on its side. Others will do it if they have to. So there's some room for clarification there potentially to try to reduce the risk of damage when a device is put on its side. We know that these are, the key is that these devices are very heavy, and especially powered wheelchairs, 350 pounds, turning them on their sides could be one of the key problems when loads are placed on parts of the wheelchair that aren't meant to support those loads. Getting things on and off the belt loader can be a challenge. And the use of the belt loader itself can be an issue. So the belt loader is for these narrow body aircraft, the way bulk loading is done with baggage. This is where the wheelchair would go up this conveyor belt. There's multiple challenges with the use of these conveyor belts. One is they tend to be fairly narrow, often not big enough to support the full width of a wheelchair. And also a second problem is that there are rollers under the rubber belt that can cause a heavy wheelchair's wheels to sink in and cause wheelchairs to slip off the side of these belt loaders. So both issues that different airlines deal with differently. We'll talk about that more in a bit. There are different devices for getting wheelchairs. Some airlines have invested in devices like these ramps and lift devices, mechanical devices that help get the wheelchair up to that belt loader when needed. In other cases, some airlines rely on manual lifting, which we think puts the wheelchair at much higher risk of damage if these 350-pound devices are being lifted manually. The use of ratchet cargo straps is another potential issue. This is an example of the yellow strap you see here. You can the challenge with these ratcheting straps, and again, the IATA, the International Air Transport Association, provides guidance on this to avoid putting these straps over delicate areas of the wheelchair, and to not over tighten them. But for anyone who's used one of these straps, it's very easy to over tighten them. It could be one, and this could be one of the reasons that we see some damage, we see some bending occurring. And so I think this is maybe one of the biggest findings that we have to share with you today, is we think we can recommend a better way to strap down wheelchairs. Here. And the last point is, people have noted limited time. So if a passenger wants to stay, as most passengers do, they want to stay in their own wheelchair right up until they get on board a plane, it means that the wheelchair has to travel quite a distance potentially to get from the loading ramp to an elevator to get down to ground level and back over to the aircraft. And that in itself potentially puts time pressure on what's happening. So these are the 6 kind of key issues that we started out with, that other people have identified as potentially being a problem. And so our work is going to focus on identifying, confirming whether these are a problem, the extent to which they're a problem, and potential solutions for some of these issues. So our next activity was to undertake some airport visits. We had an opportunity to see the baggage handling and wheelchair handling process at Pearson Airport here in Toronto. We had a chance to look inside some of these containers that are generally put into the wide body aircraft to see how wheelchairs would be secured. And this was our first, I guess, exciting finding in doing this work, is when we looked at these anchor points that are found inside these containers. So for anyone who uses a wheelchair van, these will look very familiar to you, because it's actually the same track system that is used to hold down these types of straps that are used in most wheelchair vans and public transport devices as well. And so this was a really exciting finding, to see that actually it could be relatively straightforward to move away from using ratcheting straps and moving towards something more like this self-tightening device, so that there's never any chance of over tightening a strap on a device that could cause something to break. We'll come back to that more in the future in a second here. We had an opportunity to work with an airline that took us for a tour and demonstrated the process of loading and unloading and strapping down a wheelchair. The wheelchair that you see in the picture there is actually the one that's behind me here. It's one that we had donated by Motion. They provided it to us. We're thankful that they provided it to us for this project. And we got to watch it be put in using this belt loader. Some airlines have described the challenge with getting these in, and we watch this challenge. These heavy devices, pushing them up a ramp, is a big challenge. You might ask, why don't you turn on the belt loader and use the belt to drive the wheelchair up the belt? The challenge is that, as I mentioned, some of these heavy wheelchairs, the wheels have a chance to sink between the rollers of these belts, and it is probably one of the causes of wheelchairs slipping off the side of these belt loaders. And so some airlines have decided that they will not run to prevent that type of damage from occurring to their wheelchairs. They've decided to institute a policy where they do not turn on the belt loader while there's a wheelchair on it. And so it's actually quite a challenging, strenuous process to manually push these wheelchairs up that belt. We watched as the wheelchair got secured in the cargo space. I'll talk more about the process that's used, but essentially we have there's some type of strap system that's used along with a connector that attaches to uh, to connectors in the floor of the cargo space. This is so the one other finding that we've been talking about quite a bit is the use of these single straps to well, two straps usually. Usually the way it's done is one strap at the front of the wheelchair, one of these yellow straps at the back of the wheelchair being wrapped around, as you can see. I recreated this in my office on the floor here, the way that these straps sometimes get wrapped around the base of the wheelchair near the casters. One thing you'll notice is the method that's used normally to secure these wheelchairs doesn't make use of the existing tie down points that are available on the wheelchair to secure the wheelchair. And instead what's happening is these straps get wrapped around areas that may not be able to take the forces that are applied when these ratchet straps are tightened. These are plastic parts covers in most areas. You can see sometimes the strap will actually run over the top of the motors. These are the motors that drive the wheelchair, and there's a plastic cover over top of that motor. And sometimes this strap will end up running over those motors, the plastic casings, in a way that to me as an engineer doesn't seem like it was made to support those loads in the way that they're being loaded. So thinking about ways that we could get away from using these straps and again moving towards some of those the Q-straint straps that I showed previously again highlights the potential to make use of what I've circled in red here, the tie down points that are available on many wheelchairs. This company Q-straint that makes these self-tightening these tie downs, these devices, they also offer smaller strap lengths that are designed to be used with wheelchairs that don't have the built-in tie downs, which also makes for perhaps a better way to even tie down these wheelchairs. So you can see that they just loop these little straps and then use the self-tightening Q-straint tie downs alongside those. While we were in the cargo spaces, we brought a 3D scanner. This is a laser scanner that sort of spins around when we set it down in a given spot. It spins around and captures the space in there. That's two of the members of our team doing a scan and capturing the floor space. And this is what the resulting scan sort of looks like. And you can see once we get this 3D scan, we can then take measurements. These are where I'm clicking there on the first one is one of the tie down locations. And I'm measuring the distance from one tie down location to another in our 3D scan. And the idea is that we will make use of all of these measurements when we set up to test our own measurements here in our simulation testing. So at the Kite Research Institute here in Toronto, we have what is the base of this is actually a flight simulator, which would normally have a cockpit of an aircraft sitting on top. But instead of that, we've developed a series of self-contained laboratories that can be set on top of this motion base. And the picture on the right shows the inside of one of these laboratories that we'll be using to simulate the motion of a flight, of takeoff, turbulence, and landing, to test different ways of securing different types of mobility devices. And you can see the range of devices that we're going to test in our work here. So we're not only focusing on wheelchairs, but also these motorized scooters, as well as walkers. And the idea is to strap down these wheelchairs in different ways, considering the number and the location of the tie downs that we have available, the type of the tie downs we're using, potentially using different plates that we mount the wheelchair to. We strap down to the plate, which then gets tied down to the floor, which is sometimes a solution in case if there aren't enough tie downs in the correct locations. It could be an alternative way to secure a wheelchair if there's only two tie down locations available. And we're going to think about if there are ways to protect the wheelchair from luggage falling on it. We'll think about some different cover ideas that inflatable ideas that we've been throwing around. The way we get the data to recreate the motion of a flight is using a small data logger. And this is actually the data from a little data logger that records the acceleration of a flight from Toronto to London in the UK. A member of our team who's a wheelchair user flew with and attached this little data logger to their wheelchair, and we captured the flight, and we'll be able to recreate that flight and other flights in our motion simulator to help us assess what the different tie down methods that we're going to be evaluating. The other thing you can see from this data logging information here is that when the wheelchair was loaded and unloaded, you can see there's a lot more accelerations happening compared to the actual flight itself. And that underscores our kind of hypothesis that a lot of the high risk to damage is actually during the loading and unloading. And what we will be able to see from this data logger is whether the wheelchair, when it was being loaded, whether it was tipped on its side or on its back while it was being moved around. So that's something that we're going to share with a number of wheelchair users and ask if that are flying, and we'll ask them to attach this data logger to their chair for the flight to get and to see what's happening and how do different different types of aircraft that these are going into affect the risk of the need to tip them and the different types of accelerations that they experience. We're doing a survey with passengers who have experienced mobility device damage or loss. So I think the eligibility criteria for this are flying in or out of a Canadian airport. If you've flown out of in or out of a Canadian airport where there was damage to your mobility device, we'd love to hear from you. You can go to this link, and maybe someone from our team can put that link in the chat, EngineeringHealth.ca/air. And the survey is available. It's an online survey available in English and French. It only takes about 10 minutes to fill out, and you get a gift card for filling it out. So far, we've received about 25 responses. I'll just touch on one of the findings that I found perhaps the most interesting, which highlighted that actually 60% of the respondents so far that have experienced damage was from a wide body aircraft compared to 32% from a single aisle or narrow body aircraft. I would have expected those numbers to be reversed. I would have expected to see more damage occurring in the narrow body or single aisle aircraft compared to the wide body aircraft. This could have to do with just the prevalence of wide body aircraft flights relative to narrow body. But yeah, we'll keep looking into that. We have prepared a survey for airport and airline staff as well. This has been submitted for research ethics approval. Once that's free, once that's through the process, we will share that with some of our partners at airlines and at the airports to get their perspectives on what barriers they may perceive to be in place and the difficulties they experience, perhaps that they think may be leading to some of the wheelchair damage that we see. We're running accessible air travel forum. This will happen on September 11th this year. And you can go to engineeringhealth.ca/air travel. It will be a hybrid meeting. We'll have in-person attendees in Toronto as well as virtual attendees. We're hoping to invite airlines, people from airlines, aircraft manufacturers, airports, seating, the people in charge of vendors for wheelchairs, manufacturers for wheelchairs, anyone from any of these industries, as well as people with lived experience and the people that have faced challenges with damage to wheelchairs. And so we're hoping this will be a full day event. By the way, I know September 11th sounds like a strange day to hold this kind of event. The reason we picked that day was because it follows the Canadian Seating and Mobility Conference, which is held in Toronto on September 9th and 10th. And so we're hoping we can grab some of the seating manufacturers, the wheelchair manufacturers, to come join us for this conference in Toronto. We're kind of splitting the day into two pieces. The morning is going to focus broadly on issues with and challenges with air travel accessibility. So that I've listed a few of the topics here, but ranging from navigating airports, neurodivergence in air travel, emergency egress, various topics like that. Thinking about current current aircraft, the current systems, the way they work, how they can be improved, but also the next generation of aircraft and discussions around eventually allowing passengers to stay in their wheelchairs. There's increasingly discussions and product ideas around that. So we want to bring together all the people that are working on these challenges and opportunities to make sure they know about each other so that we can create kind of a directory of people that are working on all of these topics. So that's the plan for the morning. And then in the afternoon, we're going to focus in on this topic of preventing damage to mobility devices and touching on the 6 areas that I already mentioned. We have yet to nail down our schedule, but we've already had agreement from Stephanie Cadieux, who's the Chief Accessibility Officer for Canada. She's going to come join us for a keynote. And Matthew Shaw, who's the head of accessibility practice for Rick Hansen Foundation, and he's a vice chairperson for the board of directors at Accessibility Standards Canada. So we're excited to have both of them as presenters, and we're going to try to pack this schedule full of people that understand these challenges and can help us put our heads together and figure out what we're missing from, connect the dots in terms of what we know, what we've learned, where the gaps are, so that we can kind of map out where we have to go next. If that forum goes well this year, we are planning to run a conference on the same topic in 2026. But and that's if people at the forum feel it would be a valuable thing to do, we're gonna move forward with that. So that brings me to the end of my what I wanted to share with you, the updates on our project. I'll just mention 3 ways that you can that we're looking for you to help if you're willing. You can share your feedback on anything you've heard today with us here, or I'll provide some email addresses for you to send your feedback in after the fact if that's helpful. if you can fill out our passenger survey if you're a person with that's used a wheelchair and has experienced damage to your device, or share the news of the survey with others, and register for our Accessible Air Travel Forum if you think that's something that you would like to attend. I'll just end by thanking the various partners that are helping us with this work. And there's many, many partners involved that you can see on the screen. And the members of our team. This is quite a diverse team, lots of different skills involved. It's a big, thorny issue, and I consider myself fortunate to be able to work with such a talented team to be able to take this on. And there's Allison Whiting is our project coordinator. Her email address and phone number are available on the screen, as are mine. And our project page, you can go to, I mentioned this email address or the website address already, EngineeringHealth.ca/air, and you can find out everything that we're doing.